the lone pairs of electrons on the sulfur atom of thiophene, and this is the structure of thiophene, are located in. So what we first need to do is we need to look at that sulfur atom and we need to decide on the hybridization. So if we're looking at this sulfur, we might quickly see 1, 2, 3, 4 electron groups and associate that with sp3 hybridization. But what we need to do is we need to check these lone pairs of electrons, because lone pairs of electrons can either be localized, which would make them in a hybrid orbital, or delocalized, which would mean that they would be in a p orbital. So we can only move one lone pair of electrons off of this, could possibly be in resonance. That's because you'd be lining up the p orbitals, and you can only have one p orbital that's in a plane. You couldn't have two p orbitals on the same atom occupying the same space. So we can check and see if we can delocalize these. And we see that we can. So that means that we can count one pair of these pi electrons as being part of the pi system, right? So this has 3 pairs of pi electrons. So that does mean that thiophene is an aromatic compound, right? Being cyclic and planar, having that uninterrupted system of pi electrons and an odd number of pi electron pairs. So we can associate then that this sulfur means that if it's sp2 hybridized, so we just determined that it's sp2, that means that one of the lone pairs is in the p orbital, and that'd be the one we're delocalizing. And that means that the other lone pair is in the hybrid orbital, which is the sp2 orbital. Okay, so that means we're looking at this answer here, one in a p orbital, one in an sp2 orbital. All right, and just to try to explain this further, I'm gonna go ahead and draw the orbital diagram so we can kind of picture what this looks like. All right, so we're gonna first draw this 5-membered ring. All right, and so we've got the sulfur here. And so I'm not going to draw the pi bonds as lines. I'm going to draw the p orbitals. Or I'm going to attempt to draw the p orbitals. So I'm going to draw them in purple. So every single one of these atoms has that dumbbell-shaped p orbital. And so of these ones in the ring, you've got these pairs, right? So you've got one in each. So that's one pair. One here and one here. That's your other pair of pi electrons. And then on the sulfur, you're also going to have a p orbital. And so you're imagining that this is overlapping top and bottom. So in the sulfur, you're going to have a pair of electrons in your p orbital. And so it's all lined up. And then you're also going to have the hybrid orbital, the sp2. So your sp2 orbitals are not symmetrical. You've got one lobe that's larger than the other. So we can say, okay, this is our sp2 orbital. And so we've got one electron pair that's sitting in that sp2. So we don't count this as part of the pi system because it's sitting kind of orthogonal to that pi system. So there is our one electron pair in the p orbital. And then this is our electron pair that is in that sp2 orbital.